it's incredibly important for you guys to pay attention. Step 1 is to get rid of the negative bits. And we've just done that. Step 2 now is to finish the rest of the graph, which is a big step. But in here, we have 3 sub-steps. So 3 things to consider in here. So A is to consider 1. Where is the number 1? So in other words, like y equals to 1 is what I'm saying. Where is the number y equals to 1? Part B is to consider when y is less than 1. And part C is to consider when y is greater than 1. So these are the 3 parts we need to look at. Actually, it might be a good idea to also look at what happens as it approaches infinity. So we need to start by identifying when y equals to 1. They will always tell you when y equals to 1, because otherwise it's not possible to do this question accurately. So for instance, normally they would have like grid lines for you to see. There'll be an easy like 1 marked here and probably some other numbers as well. So you can tell where y equals to 1 is. So what you do then is you find the 2 points where y equals to 1 in your parabola, or however many points there are on the graph. If you square root 1, it stays the same, right? So that means that these points stay the same, because what you're doing is just square rooting every single y value. So in this case, if you square root 1, it stays the same. If you square root 0, it's also 0. It's still 0. So actually, I should probably say that that should be y equals to 1 or 0. So these points all stay the same. So what the next step to do then is to consider when y is less than 1, okay? So when y is less than 1, what happens is when you square root y, what happens is y is going to be less than square root of y. Show you a quick proof of it. So if y is less than 1, right, that means that square root of y is less than 1, right? Then what we do is we multiply both. Oh, sorry, but we also have to remember that y is greater than 0 because we've already eliminated all the negative parts of the graph. So just to confirm that. But anyway, it moves on to root y is less than 1. That means that root y multiplied by root y will be less than root y multiplied by 1. So that means that y is less than root y. I'll write it up here. If y is greater than 1, y is greater than root y. If y is less than 1 like this, then y is less than root y. If you don't know already, you should write those down. If you do know, then good. It should be pretty simple for you then. So that means that in between 1 here and negative 1 here, the new function will be bigger than the old function. That means that the new function will be bigger. Oh, the new function will be bigger than the old function. So it'll be bigger, like this. That's what it will look like. Same here. It's going to be bigger. Remember that they share the same points. They share the points I marked in blue. So the only way for the new function to be bigger is if it looks like what I drew here. Now, when y is greater than 1. So in other words, when we consider this part of the function and this part of the function, the new function will be less than the old function, because if y is greater than 1, y is greater than root y. That means it will be less than. In other words, it will look something like this. Okay. As you can see, the new function is less than the old function. Now, here's a question. How do I know it will look like a straight line? So the answer is you have to look at the function's power. And that's when we come to part D, which is to consider what happens when the function approaches infinity. So it's y equals to x squared. This is a parabola. I know it's not y equals to x squared because it's not symmetrical about the origin, but it is the highest degree is degree 2. Okay, so we look at the highest degree. It's degree 2. If you square root degree 2 function, you get linear. That's if you square root it. So root y equals to x. Technically equals to absolute value of x, but we don't need to get into that technicality. This is only for you to visualize the situation. Root y equals to x. So that means what we end up with is we end up with a linear function, because if we square root f of x, we end up with a linear function. That means we have straight lines. Does that make sense?